Hey everybody, Dr. A here again. So I am following up with the example problem from the previous video. So this is a part 2 of the example problem where we are investigating a frame subject to dead load, live load, and wind load, and we are asked to find the maximum factored shear force, bending moment, and axial force in a vertical member AB. So make sure you take a look at that first video before you try to watch this one. So we've done the analysis. We've done our dead load, live load, and wind load analysis separately, and we found all of the relevant loadings in member AB. Now what we're ready to do is list out applicable LRFD load combos. And, you know, these LRFD load combos are listed in a few different sources. You may be using IBC, International Building Code. You may be using ASCE 7 or some other source that has the LRFD load combinations listed out. So if you're looking at all of the LRFD load combinations in one of these sources, you can pretty quickly dwindle down that some of them are not going to govern. But let's go ahead and list out the ones we think could govern. Okay, so load combination 1 for LRFD is written as U equals 1.4 dead. Load combination 2 for the loads that we have on our frame would be U equals 1.2 dead plus 1.6 live. And then load combination 3 would be 1.2 dead plus 1.0 live or 0.5 wind. So we'll bundle those up together. And then load combination 4 we may need to investigate is going to be U equals 1.2 dead plus 1.0 wind plus 1.0 live. Okay, and so obviously there's more LRFD load combinations than this, but these are the ones that we could end up governing because, again, we only have dead, live, and wind. We don't have any of the other load types on here, so we're listing the load combos that have dead, live, and wind, and that we've kind of zeroed out some of the other terms that could be in the original versions of these load combos. So now we are pretty much ready to investigate these. So what I'm going to do is I'm going to look at each effect individually, okay? So remember the problem from the first video, the part 1 of this example, asked us to investigate shear, moment, and axial force. So we need to think of this as 3 different things, okay? So think of this as like 3 questions bundled up into one. So let's look at factored shear first, okay? So with looking at factored shear first, load combo 1, okay, we would say VU equals 1.4 V dead. Now, if you remember from our dead load analysis, what was the dead load shear in member AB? Well, that was just 0. So we can see that this comes out to be 0. Let's look at load combo number 2. VU is 1.2 V dead plus 1.6 V live, okay? What is that going to be? Well, again, from our dead load and live load analyses, we can scroll back up and remind ourselves what that was. So in our dead load analysis, we said the shear force and axial force in AB is what we're looking at, and they're both 0, okay? And then our live load analysis, same thing, shear and moment in AB are 0 in the live load analysis. So when we enter into this load combination, both of these come out to be 0 and 0, and so this load combo gives you 0. What about load combination number 3? We're going to have VU equals 1.2 V dead plus, and then we're going to look at 1.0 V live or 0.5 VW, okay? Now, we have to be careful here, okay, because there's an or statement, so you want to look at what's going to create the largest effect. Well, we know that V live right here is still 0 from our live load analysis. But what about the shear due to wind? Do we have a value for that? Well, yeah, look at your wind shear diagram. Your maximum shear for the wind is 6 kips. So that is going to come into play here. And so we can then say for load combo 3, VU is 1.2. Oh, don't forget this V dead is 0. So we have 0.5 times 6 kips, which is 3 kips in shear, according to load combo 3. Now, what about load combo 4? Again, for factored shear, we have VU equals 1.2 V dead plus 1.0 V wind plus 1.0 V live. And we see some things come out to be 0 here. V dead is 0, V live is 0. And so V wind was 6 kips, so VU equals 6 kips. So for factored shear, we'll make a note here. For factored shear force in that member AB, load combo 4 governs with VU equals 6 kips. So that's one of our answers. Now we're going to do a similar process, but with factored moment, okay? So let's say factored moment. We're going to go through all 4 load combinations yet again. I'm going to go a little faster this time. We're going to say combo 1, MU is 1.4 M dead. We remember M dead was 0. Load combo 2, MU is 1.2 M dead plus 1.6 M live. What is that? Both M dead and M live were 0, so this gives us a 0. Load combo 3, MU equals 1.2 M dead plus, and we have this OR statement. What's that OR statement? 1.0 M live or 0.5 moment due to the wind, okay? And so remind ourselves, you know, what are the zeros here? We got a lot of zeros, but that moment due to the wind in AB is not 0. So go to your moment diagram from your wind load analysis, and we see that that is 36 kip feet, okay? And so that's going to be 18 kip feet as MU for combo 3. Now let's go to combo 4. We'll have MU equals 1.2 M dead plus 1.0 M wind plus 1.0 M live. And so again, we have some things zeroing out here for us. So MU is going to be 36 kip feet. And so making our commentary here, we're going to say for factored moment in AB, load combo 4 governs with MU equals 36 kip feet. That's part of our answer. And then finally, we're going to say factored axial force. And again, we're going to follow the same process. We're going to look at load combo 1. We have A sub U equals 1.4 A dead. So what was the axial force in member AB due to the dead load alone? That's 1.4 times 5 kips. So that'll give us 7 kips in compression, okay? And then load combo 2, AU is 1.2 A dead plus 1.6 A live, and we can substitute values in 1.2 times 5 kips, and from our live load analysis, we have 1.6 times 7.5 kips, and I'm going to punch this in my calculator using my TI-36X Pro here. So I get 18 kips in compression. Remember that dead load and live load, axial load, dead and live axial load were all both in compression. All right, let's look at load combo 3 now. AU equals, so load combo 3, remind us what that is, 1.2 dead plus 1.0 live or 0.5 wind. 1.2 A dead plus an or statement, 1.0 A live or 0.5 A wind. Here's where we have to be careful, okay? Remember from our service load analysis that A dead was and A live are both in compression. I'll make a little note here. Both of these were in compression. But what was the axial load in AB due to the wind load? Let's look at our wind load analysis. That was 3.6 kips in tension, okay? So you got to be very careful here because these are going in opposite directions. They're counteracting each other, okay? So let's look at both of these statements that are inside this or statement separately, okay? So here's what I'm going to do. I'm going to change colors here. I'm going to say AU equals 1.2 A dead plus 1.0 A live. All right, so AU is 1.2 times 5 kips plus 1.0 times 7.5 kips. And let's see what we get using our calculator. 1.2 times 5 plus 7.5 is 13.5 kips in compression. And then we're going to change colors again. So we'll maybe call this option A. And then option B will be AU. All right, let's color coordinate. You know I like to color coordinate. We're going to say AU equals 1.2 times 5 kips. And then we're going to say minus 0.5 times 3.6 kips. Okay. Why are we saying minus here? Well, remember the wind, the axial load in AB due to the wind is in tension, so it's acting in opposite of the compressive force, so it's counteracting it. So you need a change of sign there, okay? And so when we do that, we'll see that we'll have 1.2 times 5 minus 0.5 times 3.6. So I get 4.2 kips still in compression because this compressive effect is overwhelming the tensile effect. So it's still in compression. In either case, combo 3 is not going to govern, of course, because if you just look at combo 2, that was 18 kips in compression. So right now, that's the one that's governing in terms of a compressive effect. But let's go ahead and investigate combo 4 to finish it off. So combo 4 says AU equals 1.2 A dead plus 1.0 A wind plus 1.0 A live. Substitute my values in, 1.2 times 5 kips, and then we're going to say minus 1.0 times 3.6 kips. Again, why the minus? Well, remember this wind, the axial load in AB due to the wind is causing a tensile effect, so you need a change of sign here to counteract the compressive effect from the dead and the live loads, okay? And so then we're going to say plus 1.0 times 7.5 kips, and we will end up with AU equals, let's use our calculator here, 1.2 times 5 plus, minus 3.6, and then plus 7.5. So I get 9.9 kips in a compressive effect. So regardless, it looks like load combination 2 governs. So let's make a comment here for factored axial force in AB, load combo 2 governs with AU equals 18 kips in compression. So a couple of other comments. Notice that the same load combination does not always govern for all the effects you're looking for, okay? So notice that for shear and moment, load combo 4 governed, but for axial load combo 2 governed. Also, the maximum values, these maximum factored values, are not always in the same spot. The maximum factored shear is occurring near the base of the column, near point A, whereas the maximum factored bending moment is occurring near point B, near the corner. So you got to keep these things straight and organized when you're doing these calculations. Now, the good thing about structural engineering and applying these load effects and load combinations is that most of the time when you have a more complicated system, you're going to use some software to help you. And most software packages, you know, like ETABS or SAP 2000 or RISA, most of these, and there's a lot of other great ones out there, but most of these software packages, you can establish your load cases and your load combinations, and it will automatically go through all of these calculations for you. But it's still important to know how they work and why they work, and that's why we like to do some hand calculation examples with this. So that concludes this example. Again, this was a part 2 video, so check out part 1 if you didn't already, to see the front matter of the service load analysis. Thanks for watching.